Alright, so today I'm gonna be explaining another important article with the title Edge-Based Graph Component Pooling. So this paper in 2024 from Delft University. Graph structured data naturally occurs in many research fields such as chemistry and sociology. The relational information contained therein can be leveraged to statistically model graph property through geometrical deep learning. Graph neural networks employ techniques such as message passing layers to propagate local features through a graph. However, message passing layers can be computationally expensive when dealing with large and sparse graphs. Graph pooling operators offer the possibility of removing or merging nodes in such graphs, thus lowering computational costs. However, pooling operators that remove nodes cause data loss, and pooling operators that merge nodes are often computationally expensive. So we propose a pooling operator that merges nodes so as not to cause data loss, but is also conceptually simple and computationally inexpensive. So the main contributions are these four. We remove the hard constraints of edge contraction pooling, where always half the nodes are merged, and nodes can only be merged with one neighbor, creating a more flexible operator. Our new operator is computationally cheap, with worst-case time complexity quadratic in the number of nodes. So it's order of n2 only. We show that our operator improves performance compared to edge contraction pooling while being substantially more computationally efficient. We show that our operator does not suffer information loss by obtaining comparable performance to an expensive graph neural network that does not pool nodes. So when we have a pooling operator, we have another graph with probably much less number of vertices and edges. So this is a general illustration of our pooling operator where we show how we create the new graph. So we coarsen until we reach the final level. Our CAM stands for Cluster Assignment Matrix. Our CAM is generated in 3 steps. The first step is here, that the concatenated features of 2 nodes connected by an edge are passed through a linear operator psi and a bias form here. After applying an activation sigma, we obtain the score. So the score is between 2 nodes to see whether 2 nodes should be merged or not. And we treat undirected graphs as if both I and j are in the edge and j and I. So we acquire the subset of edges to be merged by setting a threshold. So if it is more than a threshold, then they can be merged. So separate from cluster assignment matrix, we also create a weight matrix, Well, of course, it uses the cluster assign. That contains weights used to sum the features of nodes in a cluster. This also ensures that gradients from the loss function propagate backwards to the linear layer and bias term. And now we are ready for graph coarsening. Starting from node feature X, adjacency matrix A, so we obtain the coarsened feature and adjacency matrices X and A. So the matrix U here can have values greater than 1, as it sums the number of edges between nodes that are merged into a cluster. Therefore, the min function is applied over the elements of matrix U to obtain the updated adjacency matrix, A prime, containing only zeros and ones. Finally, we rebuild the set of nodes to match the coarsened feature matrix X prime and rebuild the set of edges based on the coarsened adjacency matrix. So the complete method is provided as pseudocode in this algorithm. For details on the connected components, we refer to the reader to Tarjan and of course SciPy package. And for the data sets, they use, for example, collaboration and NCI1. They use MuTag, IMDb, PTC. So these data sets that we typically use proteins, these two, for example, for graph classification, and PubMed, they didn't do on them, but they use them for node classification. For example, proteins has only 8 features and 2 classes. So these are social networks. This one is social, Reddit. IMDb is social network. And if you look at the average number of nodes, you see that protein is so small graph, but these social networks have, for example, Reddit binary has 400 nodes, 300 nodes for multi, and Reddit multi 5K has 500 nodes.